Hello students, welcome to the class of physics. Introduction of electrostatics we have already done. Now in this section where I have left the previous one that I am starting, that is method of charging. In the method of charging, first method was in the method of charging, the first method was by friction or by rubbing. Second method was in the method of charging, first method was by friction or by rubbing, by conduction, where there is a direct touch between the charging body and the uncharged body, and by induction, where there is no direct touch and opposite nature of charge is developed. If we talk about friction, when suitable pair of two objects are rubbed together, then charge develops on it. Now, charge develops by the transfer of electron. So, which body gains electron and which body loses electron, this matter is confirmed by the fact, the electrostatic series. Here it is plus and here it is minus. In the electrostatic series, human skin, glass, human hair, wool, cat fur, silk, paper, cotton, wood, amber, plastic or balloon, ebonite. These are the common materials that we have considered, and in this any two are rubbed together, then the upper will get positive charge and lower will get negative charge. What does it mean? It means that suppose glass is rubbed with silk, then glass will become positive and silk will become negative. Why glass will become positive? Because it has lost electron and silk has gained electron. So in this way, any two member of this electrostatic series you can take and you can find that which becomes positive and which becomes negative. If we take the cotton and glass, then cotton will become negative because negative is in lower side and glass will become positive. So by proper rubbing of the two material, by friction, we develop the charge on the body. And the common example that we have considered, that the case of comb and human hair is hair and comb is hair. So human hair will lose electron and comb will gain electron. So comb will become negatively charged and human hair will become positively charged. This is the common electrostatic series by which you can easily understand that which body will lose electron and which body will gain electron. So this is electrostatic by friction. Another is conduction. In conduction, if we take a body on an insulated stand, then you see here is a suppose body which is positively charged. If this body is positively charged and we make touch of it, then some positive charge will come here and ultimately this object will develop positively charged. So by conduction, same nature of charge is developed. What does it mean? If positively charged body is touched, positive charge will develop. If negatively charged body is touched, negative charge will develop. Third is, so here it is the direct touch. So here direct touch. Third method is method of induction. In induction, there is no direct touch. Now, in order to understand the proper process of induction, we will have to again see an example. Let us try to understand and analyze the example for understanding the concept of charging by induction. In the process of charging by induction, suppose I am taking a conductor here. So conductor contains free electron, and if I brought a charged body here, this is neutral, so it contains both electron and proton. So due to repulsion, positive charge will go to this side and negative charge will come to this side. This is polarization. Now it has become polarized. Now in second step, what I am doing, I have earthed the conductor. This is earthing. When this is earthed, then what you will observe, electron will go and it will neutralize. So what is our final result? Our final result is the body is negatively charged. So whenever positively charged is brought near the uncharged body, negative charge develops on it. And if we want to develop positive charge here, we will have to bring negatively charged body. So this is charging by induction. So we have seen the three methods of charging: charging by friction or rubbing, second charging by conduction, and third charging by induction. In the process of conduction, similar nature of charge develops on the uncharged body what is present on the charging body. Whereas in case of induction, opposite nature of charge develops on the uncharged body by the charging body. If positive charge is there, negative charge will be developed. If negative charge is there, positive charge will be developed. And in the process of earthing, see, earth is a very huge conductor which can accept infinite number of electrons. At the same time, it can lose infinite number of electrons, but it remains uncharged. Because earth is a very huge conductor and few loss or gain of electron makes no difference in its charging. Now, I would like to discuss with you the concept of quantization. What is concept of quantization? Charge is quantized. Mathematically, it can be written as charge is quantized. That is, the charge developed on a body is always an integral multiple of minimum possible charge, that is the electronic charge. Here, N is your any integer. But N cannot be fraction. If I say Q is equals to plus Ne, what does it mean? It means body has lost electron, N electron, symbol E minus. So when it has lost N electron, the result is positively charged body, and at the same time mass of the body will decrease. If I am writing minus Ne, Q is equals to minus Ne, what does it mean? It means that body has gained N electrons. So mass will increase. though it will be very negligible in nature, but mass will increase. So loss of electron, gain of electron. Now we will try to understand here E. E is electronic charge. Whose value is 1.6 into 10 to the minus 19 coulomb. E is electronic charge. And this is minimum possible charge. So minimum possible charge is the electronic charge. This matter you all should remember very carefully. Also you should know that mass of electron is 9.11 into 10 to the minus 30 kilogram. This value you should remember all the time. Now we would like to understand the concept of quantization in some different way. Suppose I am writing Q is equals to plus 2E. Whether this charge is possible or not. Q is equals to plus 2E, it means loss of 2 electron. N is equals to 2. This charge is possible. Why this is possible? Because 2 electrons, 2 is the integer. If I write minus 2E, this represents gain of 2 electrons. This is also possible. But if I write Q is equals to 1.5E, here the number of electron, here N is equals to 1.5. So it is not possible. That means Q is equals to 1.5E is not possible. This is according to quantization. N should be always an integer. It can have any value, but it should be integer. Now think whether this charge is possible or not. This charge is also possible. This charge is possible because it is 4.8 into 10 to the power minus 19 coulomb. This is 3 into 1.6 into 10 to the power 19 coulomb, and this is your 3E. So again N is equals to 3. So possible. If I take another example, suppose Q is equals to Q is equals to 4.8 into 10 to the power minus 17 coulomb. Whether this charge is possible or not. Think and then try to give the answer. You will see that this can be written as we can write it in this form. This gives you so this is also possible. This is also possible if we write Q is equals to 4.8 into 10 to the power minus 17 coulomb. This is also possible because this is the charge on 300 electrons. If I say it appears that it is a fraction, but in fact it is your 3 electron. So this is also possible. So I hope that by this discussion you might have understood the concept of quantization in somehow better way. So this concept will help you in understanding the concept of quantization in somehow understandable way. Now we will try to understand the concept of charge density. In general, we interact with 3 types of body. Now try to understand. One dimensional line is there. If the charge is distributed on a line, then we define the linear charge density lambda. Unit Coulomb per meter. This is symbol for lambda, which is when the charge is distributed over a conductor which is one dimensional in nature, which has only length. Second is area. Second is area. When the charge is distributed over area, then we call surface charge density. Symbol is your sigma. This sigma is the symbol for surface charge density. So sigma is equals to Q by area. And unit Coulomb per meter square. And third, similarly, we can say volume charge density rho. Here the charge is distributed over volume. Unit is Coulomb per meter cube. So these three types of charge density you should remember and you should understand properly. Linear charge density lambda, unit is Coulomb per meter, surface charge density sigma, charge by area, charge per unit area, it is its definition, unit is Coulomb per meter square. Third is volume charge density, charge per unit volume, unit is Coulomb per meter cube. This discussion will also help you in understanding electrostatics somehow better. Now try to understand one term that is known as action of point. If I am taking a conductor pointed conductor, here charge density is very high. Charge density is very high as the radius is very small. As a result, leakage of charge may take place. As leakage of charge may take place, and this is called corona discharge. And due to this leakage of charge, electric wind sets up. Electric wind sets up, and this is the reason why in electrostatic machine sharp pointed ends are avoided. Sharp pointed ends are avoided in electrostatic machine. This is the reason. Now, one more concept I would like to discuss with you, the concept of earthing. In the concept of earthing, In the concept of earthing, you should understand that this charged body has been earth. So here the charge will be neutralized and it has become neutral. Positive charge never flows. Either electron will go to the body or electron will come from the body, go into the earth. For example, here electron will go into the earth. It is not a positive charge. Electron will go into the earth and it will become neutral. This is the concept of earthing. Therefore, earthing is a device that you will be observing in our household wiring. Wherever heavy electric gadgets we are using, we are taking a third wire called earth wire, that if somehow charge develops on that body, to prevent us from shock, what we do, we take an earth wire. So if extra charge is there on fan or on any electrical appliance, then that will go to the earth directly and we will be prevented from getting shock from it. Now we will try to discuss about the force between two charges. The force between two charges is electrical in nature. You have read in your junior classes that if two masses are there and separated by a distance r, m1 and m2 are masses separated by a distance r, then gravitational force between them m1 m2 by r square. This is the gravitational force. You should know it. Always attractive. Gravitational force is always attractive. Also, it does not depend upon the medium in which masses are kept. If we talk about the force between two charges, suppose here is a charge Q1, here is a charge Q2, and they are separated by a distance r. Here also the force acts between them. If the same charge is there, repulsive force will be there. If opposite charge is there, attractive force will be there. And that electrical force is proportional to product of the charges. And it is inversely proportional to the square of the distance between them. And when we combine this two result, then force is equals to, electrical force is equals to K times. This is electrical force. It can be attractive or repulsive. Here, K is a constant and it depends upon the medium in which the charges are kept. So this force is medium dependent. What does it mean by medium dependent? If these charges are in vacuum, then the value of K is 1 by 4 pi epsilon naught. And its value is 9 into 10 to the power 9 Newton meter square per Coulomb square. In SI system. So this is the electrical force, and here this term is called epsilon and it represents permittivity. of it represents permittivity of free space or vacuum. What is permittivity? Permittivity basically epsilon naught. Permittivity is basically tells about the electrical behavior of the surrounding in which charges are kept. With this much discussion, you might be understanding the gravitational force and the Coulombian force. This is Coulombs law. You might be understanding the similarity and dissimilarity between gravitational force and Coulombian force. Coulombian force is electrostatic, gravitational force is gravitational due to mass, it is due to charge. It will be always attractive, whereas it can be attractive or repulsive. Similar charge is there. It is medium independent, it is medium dependent. Hope you will understand this thing in somehow nice way, and in the next class I will be discussing the Coulombs law in detail, the concept of permittivity in detail, and also I will give you the meaning of dielectric constant and many other things related with the Coulombs law, and we will see some questions also based on Coulombs law. Thank you. Have a nice day.